everything else.
Hey, all you beautiful 3Ders out there. This is Chris and Mike from All Things 3D, and today it is August 29th, 2014, and we are here for our week in review. So we're going to talk about some news items that happened this week, some real exciting kind of breakthrough stuff in the 3D realm, especially in the 3D.
You look good today.
Oh, well, thank you. You do as well.
You using some new face lotion or something?
Some conditioner, Gotta keep my hair smooth and silky.
Yeah, well, our audience can't see, but we actually have a very overcast day, which actually, from a lighting perspective, makes us look pretty good.
That's right. That's what photographers actually really love overcast. Like me, I love overcast when I'm shooting people.
So do I.
Yeah.
In fact,
Soft
I have
lighting.
a lot of soft boxes to do the same thing.
Yeah. So enough about photography, and on to the 3D news items. I guess I'll pick up, or you want me to pick up with my first news item?
Please.
Yeah. So over here, let's pull it up. This is pretty cool. This is on MakeZine, so MakeZine.com. From August 25th, so a little bit earlier this week. The article headline is Sintratec Affordable Home SLS Printer Coming Soon. So around a $5,000 sintering machine is soon to be available. It has a build volume of about 130 cubic millimeters, and it's looking to be pretty exciting because you can imagine sintering is one of those ones that all of us we all watch and want to get a hold of some form of sintering in the 3D printing realm. It offers many advantages, some of which are no support material necessary, and you can recycle the material that you're not using. It's basically firing onto a polymer powder. This particular machine prints at 150 microns, or at least it's shown here in the video at 150 microns. And here you can see it for those of you joining us on the YouTube stream. You can check it out, and for those on the podcast, you can go check it out over at makezine.com and just search for Sintratec. Sintratec is Sintratec, and it's based out of Switzerland. These are some Swiss people, and they're going to offer the machine for about $5,300. So,
do you get a bar of chocolate?
Or some hot chocolate? Oh, those Swiss, they make some good chocolate.
Yep, they do, and they also make some good timepieces.
Oh yeah, they make great stuff. Yeah.
It's real interesting. A lot of people think that the 3D printing personal revolution kind of started in this country, but I don't think that's really the case. As we know with Ultimaker and a few others, there's a huge personal 3D printing revolution going on in Europe as well. So it's kind of a worldwide phenomena. And so we're now seeing the talent from a lot of different countries bringing their stuff forward. The concern I have, and I don't know if you thought about this too, Chris, is do you think there's a possibility that there's still some patent issues, or is that one of the big things that occurred in 2014?
Yeah, 2014 is the year that it's a lot of the SLS patents are supposed to break up. I don't know. I don't really know if they're licensing some technology. They may be licensing some. Those details are not included in the article, so we may need to do some research and kind of follow up next week or in the next couple weeks. Maybe even have these people on to our show to talk about their machine.
Well, that's what I was thinking. I was going to go ahead and send an email out to them and have them on, or hopefully they'll be on, but more than likely, and we'll find out more. That'll be a good question to ask.
Yeah.
Okay, so on to my item.
Awesome.
I can bring up my.
Yeah.
Where's it at? Actually, I got a tip from somebody. This didn't come from any of the news sources, so I was going directly out to Harvard, and this is a new type of, not necessarily a new type of process, but what's more importantly is the materials. They're an epoxy-based material that uses a honeycomb shape that resembles that of balsa wood. And as you're probably aware, balsa wood is very light but can be structurally sound because it's in the framing and not the material itself that creates all the structural strength. And I don't know why. Well, I'll just click through it. But you know, that's disappointing that things don't always work right. Okay. Oh well, I'll click through it. I don't know why I don't. But there's a video that you can go out to from the Harvard University. They're the ones that are working on it to actually show you the process. But again, it looks very much like other FDM printers, except it is replaced it and is using an epoxy extrusion.
Yeah, it looks really, really neat. I really like the concept. And then it's got a hair dryer, and it was interesting to watch this Harvard. It was interesting to watch this video and how they are setting up the trials at Harvard, how they're actually doing their research with high-speed videography. They have cameras mounted so that they can monitor the head in real time, do motion tracking to see exactly, do flow analysis on the epoxy. So I mean, it looks like they're taking this project dead serious from a research perspective. So I really anticipate this this particular area of 3D printing to really see a lot of growth. Because there's definitely a lot of applications for this, being able to print in an epoxy, and rather than a thermoplastic.
Yeah, and that's what they talk about, is that the advantages of using epoxies. One of them is temperature, the other is strength, and plus they can fill it with other types of materials. Here they're using a fiber, a carbon fiber.
Right, you can do glass filled, yeah, glass filled is basically the holy grail in a lot of the plastics world.
Yeah, and you've mentioned that many times. So
yeah, because you can get a lot more strength and a lot more heat resistance, and so this would be great for building aircraft parts.
Yeah, in fact, that's how they started off this article, was building the blades for wind machines for electricity, which I guess are made out of balsa wood because of their lightness, so maybe they can replace them with something like this.
Sure. Yeah, so it's really great.
So that's my item. So head on back to you, and I've got to actually physically go back to you. So.
Okay. Well, my next news item's really another. I love articles, reading articles like this. This one's over at newscientist.com, and the title of the article is 3D printed books make pictures real for blind children. So it's a little bit different direction than Braille. It actually is a combination of Braille and then taking a two-dimensional book and the picture in the scene. This is for actual visual books when children are learning to read. A lot of the books obviously have pictures in them because that's teaching you how the word, that's giving you a relation to the word. You're learning the word, but you're also learning it in a visual sense, because most people, such as myself, are visual learners. That's why having visual aids are so important. And so these people are actually taking children's books and converting the scenes and the pictures to 3D geometry that they can 3D print, so that the child can actually feel the scene in the book rather than just the Braille. So it kind of is a way. It's basically doing the same thing for a blind person that a children's book typically would. So you're getting that visual aid. You're able to feel the lamp, the umbrella, the window, the moon, the sun. Feel what those objects feel like as far as their texture, their shape, and also learn the Braille at the same time. So I think it's a real exciting project, and I'd love to maybe talk these people to come in on our show at one point as well.
Find an email address, and I'll go ahead and contact them. So my next item, but how about you go ahead and do your net? Well, actually, I'll do mine. Um, let's see where we're at. Uh, oops. Um, I don't know if you saw the
Yeah,
soundbite.
yeah. This is
We've talked
great.
about the
This is pretty.
Mcor 3D printer, and by the way, have you gotten any feedback from our contact up in San Francisco about
No,
the
I need.
camera?
I need to. You know what? I'll put that on my to-do list today. Is to put. I want to send that 3D scan of myself in full color and get it printed on the iris. See how the result is. I'd love to have it on my shelf as an example of full color Mcor print.
Yeah,
And
I
kind of
I
get a
actually
cost
sent
comparison.
I actually sent him an email the other day and didn't get a response back. There's a couple of things that I wanted to get printed as well. If you remember, Brad Herman was at Comic-Con and using the ITSEs and the structure sensor to do some capturing of people in cosplay costumes. And he had some really nice ones, and one of them was Doctor Doom, so I wanted to send that off to see how well it would print. But I haven't heard back from him, so I was wondering if you. So let me know if you get a contact from him.
I definitely have a contact. I just need to. He asked me what I wanted to get printed, and I said, "Hey, I don't have anything quite yet. I'm going to get a scan." And sure enough, you took that beautiful scan of me last week, which was
That was a few
is
weeks ago, but
or a few weeks ago. There's a couple. There's one that you took or we took at the our user group meeting last week that was pretty cool. And then, but I like the one of me in the lab coat because it's just it's cool. It like captured me in my environment, in my natural habitat of my 3D printing office.
make sure I'll send you the one with the little character on your head. I was going to actually, I might make that our banner image. Yeah, the monkey on your shoulder, except it's whatever his name is. He's the test character in one of my 3D programs. So getting back to this, Mcor makes a 3D printer that's full color, and we're not just talking limited 256 colors or 65. We're talking millions of colors. Essentially, it uses paper, reams of paper, and inkjet printing technology in order to create full color objects. And I guess the point behind this particular article is that because it can create such realistic color in objects, it obviously confused the security at an airport, thinking that it was a weapon. This is the Mcor system here. We actually saw one. I think they've made some changes to it since we've seen it, but literally it cuts out layers of paper in just like a standard slicer, but instead of using plastic or UV resin, it uses paper and literally a razor blade, and then uses an inkjet to color the perimeter, the one that's actually exposed on the exterior, of the color of the object. So with that being said, here is the hammer that was actually created. And yeah, it looks pretty much like a hammer. So it's got nice, vibrant colors, very realistic. So it's very nice. And then they show something else that they've been showing. This is a 3D printed iPhone with the screen. And as you can tell, I mean, if you look really closely, you can tell that it's a 3D print. But from a distance or first glance, it looks like an iPhone. So it's good for creating models. And if it weren't for the exorbitant, well, I mean, obviously you've got a Fortis 250, but even so, I think their cost just for the unit itself is 40, but full setup and instruction is like 65,000. So it's a fairly expensive machine. But there hasn't been that many. We've been looking for a place to actually get some prints, and it's really difficult. Here's a full color, obviously, bust of somebody, literally just the head. I'm not so pleased with this. They could have provided a better example, and I don't know if that's in the scan itself or maybe the processing. Then we get to an orange, and again, it's vibrant. So yeah, I think it's got some potential, but we've looked at it before. We're looking for service bureaus that are carrying it, and for some reason in this country, there doesn't seem to be something like that that specializes in the Mcor for Service Bureau functionality.
Yeah,
I
I think it just is. I think it's like any business. It just takes a little while to get off the ground. I think Mcor definitely has a niche. They'll definitely find it. I think for GIS mapping, they've got a winner there for doing topo maps or site surveys. Or like you said, even simple models for if you were going to pump out a lot of models, paying for paper is a whole lot less expensive than paying for proprietary thermoplastic cartridges. You know what I mean? So I think they've got a great product. I think they are finding some market reluctance because they had basically a subscription service kind of pricing for the consumables. So they found some market reluctance there. Another thing is it is an Irish machine. Not saying that there's anything wrong with that, because there are some great technology companies out of Ireland. But when it comes down to it, as far as serviceability or support, buying a machine from Ireland, you're going to find people reluctant to buy an Irish machine, whereas the Japanese or the Swiss or the American-made machines, those are they have kind of a more solid reputation, a lot for serviceability and support. So, but other than that, I think it's a great machine.
Yeah, that's true. It's untested, and it's not a very large company. So, like a lot of the startup 3D printing companies, that could be an issue. But I'm more concerned that you've got a product here that it would fit nicely in a service bureau like I want to say Sketchfab, but Sculptio and Shapeway, but you're not seeing anything like this. And maybe it's because they've been pushing more of the 3D system full color SLS systems. But yeah, I do think there's, like you said, a niche for this, and then but I would like to be able to actually print something that we make and see what it really turns out with, and that's been hard to do. So hopefully either you or me will have something soon to show.
Yeah, the other big drawback that I could see from a service bureau standpoint is support removal is unpredictable, because it's you have to weed out paper. Sometimes some models are not going to be very easy to weed out or to clean out the support material, because essentially it comes out in one big block of paper, and you have to take away. So for solid mass parts, or even a map that has a flat face on the top or whatever, those are easy to weed. But if you have a really intricate, complex geometry, it's going to be either impossible or really hard to remove the paper that's inside of that geometry.
Yeah, well, I mean, there's a couple of ways you can do that. One, you identify in your instructions before you send it to them that this is the type of models that we can print with any quality, and then obviously you have a QC that identifies that and rejects it if it doesn't fit those boundaries, or you just send the whole block and leave it up to the person who sent the model to clean it up themselves.
Yeah,
I mean,
but when it's competing head to head with SLS technology, somebody like Shapeways, for instance, they have their process is fully automated. So the model, they don't even check the model or make sure they don't check the model for you. You click a user agreement that, hey, when you submit the model on the website, you're going to get what you sent them, and then it automatically goes through software and goes right onto a build tray somewhere. Nobody's really going in and checking if it can be weeded or not.
Well, actually, that's not quite true. If you go back and listen to my interview with Katz from the lead engineer out in New York for the Shapeway there, they do literally touch each of these items and
yeah, when it comes out of the machine, right? Yeah, that's
no,
when it
actually
yeah.
Before there's I agree that there is
but a lot less so. It doesn't require as much manpower as the Mcor machine. Whereas so I think there's going to be we'll see some interesting business models built out of the I mean, I consider it an LOM printer. Mcor claims that it's not a LOM printer, which it stands for laminate object manufacturing, because it uses a blade instead of a laser. but I still consider it a form of LOM. And yeah, so I think there's still plenty of room for these markets to find a use for these Mcors. I just think it's going to take some time to build a reputation, and they're definitely going to have to get competitive with their pricing when they're going to try to compete with these new sintering machines that are going to be hitting the market.
Well, and that's another point, is that even 3D System isn't standing still, and their coloring process is becoming better.
Oh, definitely.
So I think they had an opportunity last year, and as you said, they've stumbled. Let's hope that doesn't hurt them too much. As you know, there was somebody down in LA that was supposedly going to be their distributor, and that kind of fell through. So we'll see where it goes, but I do think full color has a lot of potential, especially in human beings, 3D modeling and so forth. But we'll go. So what's your next item?
All right. So next item here is another cool one. It was a busy week. This one is Sciaky Inc. is going to introduce an EBAM machine to the market by September. EBM machine is an electron beam additive manufacturing. Is what EBAM stands for, and this particular machine, will do up to, the build envelope can reach up to 19 feet by 4 feet by 4 feet. So no price quite yet, but if you head over to engineering.com, you can check this video out of the EBAM machine working that they are working on, and show you some of the possibilities. So it starts off with your 3D model, obviously, and it doesn't make a perfectly clean model, but when we were at the Maker Faire, we saw some people working on technology kind of like this, using welders, but this company apparently has come up with their own electron beam type manufacturing. So what it does is it basically rough 3D prints the model. We use it out of either stainless steel or titanium or all these different metals that it'll it'll print. There's quite a few that are numbered in the video, listed in the video. The machine comes up with the tool path. It electron beam manufactures it using additive manufacturing, which is pretty cool because you're saving on material, and then it goes into be machined, post-process machined after that, to be to come down to the exact precise geometry. So it's basically a way of using less material when you're building either a mold or a tool or something that needs to be built out of metal, even much quicker, obviously, because you don't have to machine as much. I mean, you're talking about a fraction of the machine cost, so less wear and tear on your bits, your actual machines, your CNC machines. So pretty cool. It's just another way that additive manufacturing is growing, growing so rapidly.
Yep, that's pretty cool, and obviously a new technology that can use a variety of materials. Yeah, it is somewhat crude, but in some cases, crude can be finished further afterwards.
Right.
So, okay, moving on to my next item. We seem to have a section just for medical, and obviously there's more medical news. So let's head off to my item. This is another article from 3ders.org, and I think also 3dprint.com has done something similar. But essentially, if you notice the size, this is a child's skull, but the Boston Children's Hospital is using 3D modeling in order to provide accurate models for both the surgeons as well as for training. But they're doing something more unique than some of these others, where they farm out their printing technology or processing to an outside vendor. They opened up their own shop. And here's some other example. This is a heart and its ventricle systems. So like I said, in-house 3D printing. They talk about a resolution of 16 microns. Do you know of a printer that does 16 microns?
No.
Yeah, so I'm kind of wondering about that. I don't know what this is. It has their logo on the front, but it would be interesting to find out what that is.
Oh, that looks like an object Connex machine.
Does it? Yeah,
Yeah.
okay. So possibly that would have a 16 micron resolution.
Yeah, I would say that PolyJet is probably the finest of anything I've seen. Yeah, either SLA or that, but that's a PolyJet machine right there.
Yeah.
I think that's a Connex. It's one of the Connex
Okay.
machines.
Well, we can look it up later. But what's nice about it is, oh, yeah, here's some actual models taken from it. So uh, they're able to, because they bought them in, are in-house, they're able to do these in hours versus days that other vendors or outside services would provide to them. So they can immediately take CT and MRI scan directly to this, create the models, and have them for planning. And, getting back to what I did months ago with the neurosurgeon that worked with my wife is created a 3D printed skull that included her meningioma, which was in the upper orbital roof on the left hand side, which clearly showed it. Now, obviously, the resolution is, I wouldn't say better on this particular machine, but I would assume that their CT and MRI machines are probably more accurate than the one that was used with my wife. This is probably in the 1 millimeter scan.
And you had a
It's
3 millimeter
3 millimeter, so you could actually see the
layer
layers more
lines.
dramatically.
Right.
But again, here, one of the things they're pointing out in this case is
Oops.
that it actually show the grid that's used for the electrodes for somebody who has epilepsy. Um, and then obviously they can show 3D printed and do all the markings and so forth, as he's showing here. So, as we've already talked about before, and I know from personal experience, this really helps a surgeon physically locate and work with a patient, because they don't have to open them up in order to find this out. You don't have to do any exploratory surgery. You can work directly from this, the
Model.
skeletal structure, or even with MRIs creating organs and so forth. So this is great. And I want to say, we've got Steve Piper that we've had on several times. He's in this area, so it would be nice to maybe get him back on and talk about it as well. But this is really exploding, and obviously I have a personal reason for being aware of it. And just for our audience, we plan to do another live Goa presentation seminar in October on 3D medicine, where we're going to talk about all the different processes and how 3D is being used in medicine. So little plug there. If you're not doing much on October 15th, you might want to join us. But again, this is actually a really nice model here. I actually kind of like this one. And
yeah, it's real smooth. So here, this is what I'm assuming the printer is. The Object 500, either the Connex or the Connex 3. This is the new Connex 3 that does multi-materials and multicolor all in the same build. This one has a 16 micron high-quality resolution. So
then you're correct. What do you think that cost?
Oh, the Connex 3, probably, I would say probably somewhere in the 100 to 125K range, and then your consumables, are fairly expensive. These machines now, they claim you don't have to run them all the time, but really you do. The heads will get clogged. They have purge mode, or they have a mode that it'll automatically go into, but you do need to keep the machine on. It doesn't have to stay in live mode, but there is a standby mode, so that it'll keep purging a little bit of material, so that the head doesn't clog up. Obviously, when you're talking about 16 micron resolution, it's basically based on inkjet technology.
Yep.
And you're passing through a photopolymer resin through the inkjet head. You can't leave that resin in there without it curing,
Yep.
to some degree.
Well,
So
I would assume that the technology in the head itself prevents it as well. There's maybe a Teflon coating or some other material that
yeah,
prevents it from building up as
and these
well.
these heads are extremely expensive too. So
Hmm.
when you drop a head, it's even worse than dropping one on a production grade inkjet printer, obviously, because
Well,
yeah.
that's where
So
service contracts come in. So
yeah.
let's move out of the news and into our own personal projects. And it looks like both of us are still in medical, so it kind of ties into that. So do you want to go ahead and talk about yours first?
Sure. I could bring it up. Let me just bring up the Talon here. The one I've been working on here recently with one of my peeps is the uh, 3D printed robo hand for one of my customers has his kid is missing his left hand, so we've just printed him a left hand, and so his dad has been putting it together. I did the 3D prints, and I've been actually looking for somebody to do this for quite some time, and finally found somebody who just happens to be my customer, and uh, I can't tell you how fulfilling of a job this has been. This has just been so awesome, and really thankful to these people out there at enablingthefuture.org for open sourcing these models, putting them up on Thingiverse. Uh,
Well, let me segue into that.
yeah,
Just to let you know that we did get an acceptance from John Scholl, who is the founder of eEnable. So we're going to be doing an interview with him next Tuesday at 10 o'clock in the morning Pacific Standard Time. So if you're out there and you want to listen live or catch it later on in the week, you'll actually hear from him himself on why he was motivated to move in this direction, and so you'll be able to answer or ask any question you want to him, Chris.
yeah, and for those of you that want to know more about 3D printing and helping in the future, definitely go out and check out SciGraph just ended in Vancouver, and the keynote speaker was a man, a really great guy, just really inspiring. Elliot Kotek, he's the CEO of and co-founder of Not Impossible Labs, and he kind of tells his story of how they're using technology / 3D printing in all kinds of projects to help humanity. They did this really inspiring project using the robo hand over in Africa for people that are losing their limbs. So just a really inspiring talk. So if you have an hour that you want to dedicate to improving your own self by raising awareness or feeling inspired, go out and watch Elliot Kotek. It's a really great talk. SciGraph had a lot of great info this year, and can't wait to go through some of it and maybe sift through some of it to give our listeners next week.
Make sure you send me the link so that I can put it in our show notes.
Definitely.
Okay, so on from there. If you remember, last week I talked about being involved with using 3D scanning and 3D technology for dental work, and I used myself as a subject. And so I'm going to kind of give you some images of the progression. So essentially, what we did is we used the intraoral scanning system to scan a set of teeth, which included a cavity that was cleaned out. And from the cavity, I am creating what you would call a positive of it, and then I need to clean that out. So I have a series of images that I'll show you of my progress with it. So this is the actual cavity. I use what they call negative volume. Literally took the teeth and then subtracted a block from it, which gave me a positive. So now the objective is to clean it up further. And here you see that I cleaned it up and actually fit it back into the tooth. So believe it or not, even though I do own some fairly expensive tools, the one that I found the most effective with using this is a product called Autodesk Mesh Mixer, which is free. They have come a long way since last year. It rarely crashes. It seems to do very good volume processing and subdivision, which gives you the organic tools that you need in order to sculpt, which is basically what a lot of what do you want to call it? Dental work is sculpting crowns and in this case a filling. So as you can see it there, and then I can actually I'll jump over to let's see my application. Where's my screen at? Let's see. It shows black. Yeah, I don't know why that happens. It must be 3D applications do not show up in Google Hangouts, so I guess I can't show it to you. But I wanted to, let's see if I can do a screen capture real quick. Okay. Let's see. Give me a moment.
It probably has, yeah, I don't know why. It probably has something to do with whatever language it's built in, or...
Well, it uses OpenGL, and I think it doesn't provide a conduit directly into Hangouts. Because I've tried a couple of 3D applications, and they don't show up.
Oh, there you go. That's pretty cool.
Yeah. So what I've done here, one of the things that we need to do is what they call the bite locations, so that when you put in the filling, which I showed you earlier, you can't see it here from the static image, but you want to make sure when you bite down that you're not biting on material, because it creates pressure, and obviously that'll inflict pain if it's close to the nerve
yeah.
or two.
Yeah.
So you want to make sure that you have some clearance there. The problem is in using it this way, there are no markers per se to identify where your depression is, so I'm kind of playing it by ear. The actual software that comes with the iTero has tools for this that allow you to put the material in and then do what they call bite simulation. So the problem is you have to have the actual scanner system, which is I think a $50,000 scanner, so it's not something that I'm going to get anytime soon. But we do have a local dentist here. His name is Dr. Dan Copp, who does this, and I do know that there are others that are using it. What does it do? What's the advantage of it? Well, obviously you can manipulate everything in a virtual environment. You can do more precise molding and manipulating, and then you can, in my case, I'm going to print this either on my Form 1 or the little RP to create a model and then send it to them, and then they're going to cast it out of a gold alloy, and then we're going to put it back in my mouth next week or the week after. I've got to hurry up. I've got a temporary in there, so I'm on a time clock. But that's the whole process, and it's moving along. And I mentioned this to Jesse at Autodesk, and they want to do a blog item on it, so that'll be kind of cool.
Yeah.
So that's kind of my project this week. And so what kind of products have you been working with?
Well, like I said, the RoboHand has been the big one for me. Yeah, and other than that, just went solid state on my computer on my main workstation. I can't begin to tell you how much of a performance gain solid state gives. It's just unbelievable. I think solid state is the single most important thing that you could do to a computer. There's no reason to throw away your i3, your i5, your second gen i7. They work just fine. The processor's usually not the bottleneck. Usually it's the hard drive. So for me, solid state all the way.
Yeah, I've actually gone back into the previous generation. I've had some quad-core machines that they run about 1.2 gigahertz, which is more than adequate for a lot of things, and just put an SSD in them, and it's like having a brand new machine. So totally agree with you there.
Yeah.
So I do have a couple of products. One of them, if you remember last week, we talked about the Japanese company that is creating gummy bears, or as I call them, gummies. So I thought, well, how hard really is that to do that? If you print out a positive, how long does it take? So I did a little searching on Amazon, and I came up with this. It's called EasyMold. It's a silicone putty, so if you ever played with clay, you just knead it. It's a two-part system. You knead equal parts, and you've got a minute of kneading, and then you've got 2 minutes before it sets. So literally, you knead it and create a little flat object, and then you take your positive, whatever you printed, and you press it into it. So obviously, the amount of material required for the mold depends on how large your object is. So I did this, and it created some fairly good molds. Now, obviously, it was my first time. I pressed it a little harder than I should have, and actually it comes in two materials here. You've got the purple and the gray, and when they mix together it creates a lighter purple, and I guess that's why the container is purple, and then creates this mold. And it's pliable, which is great, because over the last week I've created, I know you're salivating over there, Chris, but different types of confectionery. This is white chocolate, based on my gypsy queen, and it works pretty good. And here's a dark chocolate, and also I did hard candy. This is a mint.
Wow.
And then also I did all of them in the 3 different versions, but here's a me stark in hard candy. And then if you remember, on Tuesday I brought in mint. I did some actually gummy me's, but they melted. That's why I asked you for the beeswax. I found that the secret ingredient to, is it Haribo? Harboy? Yeah. It's the German company who actually created gummy bears, or gummy bears in American. I think the secret ingredient is beeswax that gives them the more firm texture. Other than that, it's just gelatin and then some flavoring. That's not very sophisticated. But again, there's a whole
tray of them.
Over there. So it's kind of a fun thing. Plan to do a little article on it, but it's really easy to do. And essentially, I would go with something maybe 2 or 3 inches in size versus smaller, because it's just a clay impression. And then the other item, very quickly, that we kind of talked about on Tuesday, is Matter and Form. It is a tabletop 3D scanner, and believe it or not, it works. Tried it out last night. One of the things that I noticed versus the NextVision is a little slower, but it does create some decent models. The nice thing about the Matterform versus, let's say, the what is it? The MakerBot scanner, is that it doesn't have a fixed scanning head. It actually is on a Z-axis, so that it moves, so that you can actually get a better height. But more important, it brings the camera closer, so you have more resolution, which is what's required in these type of things, because it takes snapshots of laser deformation information, and it uses that to subtract and use to create the point cloud. And obviously, the more resolution you can get, the better. So instead of moving the camera back to get the whole object, it moves it closer and then rotates or pushes the Z up and down in order to take it in sections.
And it's in a finite basically Z step. So you can control. It knows, oh, it moved 0.1 millimeter up or down, rather than having it be kind of rough or doing it by hand.
Yep, exactly. And I think it crashed on me, but no, it is. Let's see if I can bring it up, and unlike the other software, will it show up?
And this was a Kickstarter.
This originally was a Kickstarter almost a year ago, and it's not showing up, so I guess it doesn't see the application. But I can, I'll take a little snippet real quick, and then we'll go from there. It's a very clean interface. There's not a lot of accessories to work with, but as you can see, it's got a home button, an open for previous models, export, combine, and clean. That's once you scan. The scanning function is very simplified. There's an advanced feature, so if you want to modify things like the Z step, as we just talked about, how you also have to rotate the the carousel or the platform. You can determine how many degrees, and this all becomes dependent on the how much texture is on your 3D object. And obviously, a smaller or a smoother object doesn't require the same number of movements because there's not a lot of surface detail that you have to capture, which means it will take less time. More rotation or more rotation steps, more Z if it's higher is always obviously going to take more time. So this can take anywhere from 5 minutes to an hour to scan something. And currently it does color, but it will not export color. That's coming soon. Yeah, there's really nothing else in its price range. I think it's about $600. It's a Canadian company, and again, it's a matter-in form. I think it's going to be a nice little project. I think it'll do really well in the educational system. It'll give kids an opportunity to bring in their little toy, scan it, and then manipulate it. So it's just another option there. And yeah, hats off to them that they finally pulled through. They had, like a lot of things, they had a lot of challenges. One of them was meeting FCC approval. The other is they had some hardware issues, and obviously they're refining their software, but it looks like they went through and put together a nice little product and is able to move forward with it. So hats off to Matter Form. Very cool. Okay, so I think that's about it for me. Chris, anything else? I think we got, what, a few items to talk about. Oh, you got a tip and trick for us.
Yeah, I can give you another tip on. I have a question on my ABS prints are warping. Where do I start? Person was writing in saying that he has an Airwolf printer and he has a heated bed, but his ABS is still warping. There was actually a Printmeister wrote a response, and I'm just going to read it off because it's a great tip. So with ABS, make sure your fans are not blowing on your print itself. A lot of the times you see a fan that's blowing onto a print. That's usually for PLA. PLA doesn't suffer the same type of warping problems that ABS does. If you're blowing, you have an exhaust fan, make sure that it's blowing up and not onto the print. Close the windows and eliminate drafts in the room, and keep the doors closed. And you want to keep the ambient temperature of the room at about 70 degrees Fahrenheit. So that's a good tip. Obviously, using a slurry, using something for it to adhere to the bed, and keep the bed hot. So keep it at about 110, 115 C if you can for the bed, because what that'll do is keep those lower layers nice and hot, so that the hot layers are not are cooling at the same temperature that the model is keeping. Keeping your bed hot at about 115 C will ensure that the body of the rest of the model is not going to cool at a different rate than the layers that are getting laid down.
Yeah, that's extremely important. And to add to that, if you have a framed printer, that's like a Maker, well, actually Maker bots, unless you have the 2X, do not print in ABS. But if you have, let's say, a box type 3D printer, you might want to look at containing it with acrylic or panels or something, and maybe a fan system to control the temperature as well. Aftermarket, I don't think there's an issue of you being tagged as a patent violator, but there's a reason that Stratasys encloses their units, because it allows you to create an even temperature, which also prevents warping. So if you can do that on top of everything else Chris mentioned, that will really help too. And as a side note, PLA can warp as well. It's not just so. I think it's almost the exact opposite. You want, again, it's temperature differential that plays a part. So thank you, as we call you, the Print Whisperer.
Yeah.
Okay. And so upcoming events, we've got a few. We've got an interview with Dr. Dan Copp, which I've been accumulating footage, so and I think we're going to finish it up today. Chris, if you're not too busy this afternoon and want to join us, I don't know exactly what time, but he'll be in my slow office studio. And if you want to join us, I'll have the Google On Air set up so that we can talk to him, and we're going to kind of go over my filling and talk about the whole process. So it'll be real interesting. And then, as I mentioned already, John Scholl will be with us next Tuesday at 10 a.m. And then hopefully we're also going to talk to Dr. Cleos, who does YouTube educational videos on MRI and CT scanners. He is a board-certified radiologist, I think, in Florida. So we'd be glad or interesting to talk with him as well. All right, Chris, why don't you end it for us, and then we'll call it a day.
All right. Well, thanks so much to our listeners for joining us on August 29th, 2014, Week in Review. Hope you learned some stuff. Real exciting buzz out there coming, and regarding the 3D printing technology, obviously. And we will see you next time.
Yep. Bye.